right? So before we finish this duality property, so I just wanted to write our analytic function xa of t in terms of block diagram. Okay, what did we get here? We got xa of t to be x of t convolved with whom? Delta of t plus j by pi t. So clearly, because convolution is involved, LTA system is also involved. So how do you put this in a block diagram notation? I have x of t, okay, and this fellow is passed through an LTI system whose impulse response is how much? Whose impulse response is delta of t plus j divided by pi t. And what do we get as output? Instead of using y of t, we use xa of t. Why? If you convolve x of t with delta of t plus j by pi t, you get analytic signal, which is equal to x of t plus j times xh of t. That will give you the analytic signal. Okay, so what is the impulse response of analytic signal here? That should be delta of t plus j by pi t. Okay, yes, as the last topic, we want to look at the impulse response. Okay, so we'll talk about what is called Hilbert transformer. Okay, so we have already seen that. We will see this a little more information about that. Okay, so Hilbert transformer. Okay, so this fellow block diagram can be written like this. So what is that? X of t, it is passed through Hilbert transformer is LTA system with impulse response how much? 1 by pi t. So what will be the output of the Hilbert transformer? We get xh of t, which is equal to x of t convolved with 1 by pi t. Okay, so because convolution is involved, so this implies what? Hilbert transformer is linear and time invariant. Okay, so Hilbert transformer is linear and time invariant. But is it causal? Is it a causal system? No. Why? What is the property of a causal system here? Let us plot the h of t here. So how does the plot look? So for negative time, the plot looks like this. For positive time, the plot look like this. Okay. So what do I mean by that? It means that the Hilbert transform's impulse response will exist even for t less than 0, and hence what do we say? That function or Hilbert transformer is not a causal system. Okay, as h of t is not equal to 0 for t less than 0, Hilbert transformer is non-causal. Okay, so what is the property for causality of LTA system? The impulse response should exist only for t greater than or equal to 0. For t less than 0, it should be 0. But for Hilbert transformer, what is happening? It is non-zero for t less than 0. And hence, what do we say? We say that Hilbert transformer, what do we say? Hilbert transformer is a non-causal system. Okay, and because it is non-causal, we say it is not memoryless. As it is non-causal, we say it has memory. Okay, it has memory. So, and you can clearly prove that this is an unstable system. So how do we say that? What is that we have to do? We have to take absolute integral value. Okay, so if you take absolute integral value, this should be equal to, so if you take absolute value, what will happen here? You will get integral 0 to infinity. So I'm just simplifying this. You will get 2 by pi 1 by t dt. So you can easily see that this is equal to infinite. Okay, so because this is infinite, so what do I mean by that? We say that Hilbert transformer is unstable. Hence Hilbert transformer is unstable. So what is Hilbert transformer? With all the, we'll combine all of them. So Hilbert transformer is linear, time invariant, non-causal, not memoryless, and unstable system. Okay, yes. So with that, So we are done with all the 13 properties of continuous time Fourier transform. Okay.